On this website, we're gonna be talking about bacterial resistant patterns in hospitals, and what we're gonna begin with is what is the current population size and distribution. So we're gonna start with population characteristics, and as of right now, we know that 136 million bacteria exist globally in hospitals, and 52 million reside in China, and 119 million in the middle class and usually low-income countries such as Pakistan and etc. And it's very important to see what growth pattern bacteria show in hospital environments, which in general, the bacteria growth patterns is divided into multiple sections of patterns, which it first begins with the lag phase, as you see in the diagram, and then it goes into exponential, stationary, and death phase. So the lag phase is basically the initiation of growth and it's the stage of reproduction, and after that, we go into the exponential phase, which most of the bacteria cell are being divided by binary fusion and doubling in size every time. And the high metabolic rate leads to a very huge amount of bacteria being grown and reproduced. Also, antibiotics in any form or anti-infections are very effective at this phase because the parts of the cell that are just forming are targeted and there cannot be that much resistance formed. The population eventually, however, hits a stop in growth and plateaus, which is called the stationary phase. This is due to lack of enough natural resources and what we call a cap in the capacity of the environment. So the carrying capacity in this case is very important at this stop and plateau that we see. And under conditions such as in hospitals, nutrient competition increases and cells become very much less active in general during this phase. And then this amount of antibacterial and resisting factors such as less favorable conditioning and hygienes, etc., initiate the death phase, which is what you see in the diagram as the last phase of the diagram, which is a decrease in the log of number of bacterias. As bacteria die, they spill their cell content into the environment in order for other bacteria to use them and grow on later. And the same cycle repeats itself for other bacteria and taxon as well, which means that after the death phase, the resistance decreases and then the loop begins itself once again. And then we're going to be moving on to major limiting factors, which are quite obvious. One of the limiting factors is oxygen. And the other one is temperature, the other one being moisture and pH. These are very important because usually bacteria require these environments, some very optimal environments to grow in. And if any of these factors based on the conditions are altered or changed, it could positively or negatively affect the taxons and therefore the abiotic, ambiotic factors. So an increase in antibiotic concentration decreases in surface, extreme temperature or extreme pH, low oxygen levels are some of the very important limiting factors that we're going to be taking into account for the rest of the research and for the rest of the website. And the host immune response is also very important. That is a biotic factor. And that is if the host can itself kill the bacteria with its improved immune system. And there are also indirect factors such as the food, such as the hygiene, such as the country that the person lives in, that the host lives in. And despite all of these restrictions and limiting factors, the microbial communities are very large and diverse, and they often still resist against such limiting factors and lead to some taxa surviving and thriving in different environments. For example, if a taxa cannot live in a very cold environment, probably there are going to be some taxons that can live in that condition. And that will basically be it for the presentation. Enjoy the website and have fun.